Good morning, Algebra 2. We are going to cover Lesson 72, Properties of Logs. So this is going off some of the stuff we've already done with logs. So that's writing it in exponential form and inverse properties. And so this section covers several properties having to do with logs. So I'm going to start with inverse properties. So there are two of them. First is if I have a base, and then in my exponent is the log of the same base of any argument or any answer. If the bases are the same number, then everything cancels except for x. So this is assumed that b is the same number. The opposite is true if it's written in log form. So if I have log base b of b to the x, again, if my bases are the same number, then everything cancels but x. There are three additional properties. One is the log product property, the quotient property of logs, and the exponent property of logs. So I'm going to go ahead and write that down. These are in your books. It's a little repetitive. The product property states that if I have log of a base of m times n, that can be written separately as two different logs, log base b of m plus log base b of n. Okay, so that is the first, and this can be written right to left or left to right, but the sum of two logs with the same base can be written as a single logarithm if you multiply the two parts, the m times n. Now the opposite is true for quotient, so if I have log base b of m divided by n, division is the inverse of multiplication, so when I write these two logs separately, I'm going to use the inverse of addition. So log base b of the top part of your fraction minus a log base b of n. Now remember, these properties work left to right and right to left. Last is the exponent property. So if I have a log base b of m to the nth power, I can bring that exponent right out front. It has the same value. So it'd be n times log base b of n. So lesson practice, we're going to jump on in. I didn't write the page number down and I apologize. So we're going to start with part A and B using inverse properties. So part A gives us a log base 10. Whoops, it's written in the reverse. And I'm going to space this out a little better. So part A is 10 to the log of 3a minus 1. And they'd like us to simplify. Now, when I see this, I notice the base of my exponent is 10. And the invisible base of my log is 10, but it's so common they won't write it. So if you don't see a base, it's an invisible 10. So these cancel, and I'm left with just 3a minus 1. That's it. So part B, they gave me the natural log of e to the x plus 1, and we're going to simplify this. Now ln is natural log, but they write the acronym backwards, so log natural, and the invisible base is an e. So notice I have natural log e of e, so this cancels, and I'm left with x plus 1. So that's it there. These are the inverse properties. Okay, so the second part of our notes, we're now going to work on evaluating using the change of base formula. So the only two logs on your calculator, you have two buttons. Whoops, that's not how you spell calculator. That isn't at all. On your calculator, abbreviated, you have two boxes, log and ln. This one has a base of 10, and this one has a base of e. Now, the problem is most of the time we're given problems that don't have these as a base. So how can we use our buttons when we're given a different problem? So I'm going to show you how. So if I have log base 2 of 8, I'm going to convert this to a base of 10. And what we're going to do is we're going to take the log of the answer, log of 8, divided by the log of our base. The base goes on the bottom. And so the way I remember that is they both start with a B. Base goes on the bottom. So I'm always coming up with ways to remember it. So this is how we're going to enter in our calculator. So you would say the log of 8. Make sure you close out the parentheses, divided by the log of 2, and you get 3. Now the reason it's 3 is because 2 to the third equals 8, and the answer to a logarithm is the exponent. So let's try the one, and let's try another one. Log base 6 of 48. So this is going to be a decimal because 6 to the what is 48 is not a nice number. It's going to be a decimal. Because 6 squared is 36, but 6 to the third is 216. So it's somewhere between 2 and 3. So the way I'm going to enter this is the change of base formula. So I'm going to do the log of 48 divided by the log of 6. So using our calculators, the log of 48, close out your parentheses, divided by the log of 6, and I get 2.16, not 61. So using that knowledge, let's do part C of our lesson practice. So part C says to evaluate log base 32 of 64. All right, so we're going to do log of 64 divided by the log of our base. And I'm going to enter that in my calculator. So log of 64 divided by the log of 32. And I get 1.2. All right, so this first part of our notes is inverse properties. The second part of our notes is change of base formula. So I went back and kind of highlighted through. Now the third part, I'm going to show you how to use our product and quotient properties using something we call approximating logs. And this is going to come in handy because I can use this without a calculator, especially if I'm taking like an iReady diagnostic or some kind of test. So I'm going to do one with you. So here's an example. Find the log base 3 of 63 using the fact that the log base 3 of 7 is approximately 1.77. So when we're approximating logs, especially when we're taking like the SAT or the ACT, if it's a test that doesn't allow us a calculator, they will often tell us the value of a log. So the first thing I'm going to do is I'm going to rewrite 63. So this would be log base 3, and I'm going to use the number they gave us. So I can break 63 to be 7 times 9. Now, I'm going to use that property I wrote in the beginning. I'm going to use this product property that states log base m times n can be written as 2 separate logarithms. So I'm going to write this as the log base 3 of 7 plus log base 3 of 9. Then I'm going to replace, I know what this equals. They told me up here. So I'm replacing that first part, so I have 1.77 plus, this one's easy, 3 to the what equals 9? 3 squared. So the value of this log is 2. So 1.77 plus 2 is 3.77. So that's how I can find the value of this log without the use of a calculator. Now we can check our work. What's the log of 63 divided by the log of 3 using that change of base formula? And look what we get, 3.77. So let's do some lesson practice. So part D, they want us to find log base 2 of 40. Given that the log base 2 of 5 is approximately 2.3219. Sorry, my computer timed out. Okay, so the first thing I'm going to do is rewrite 40 using 5. So 40 is the same as 5 times 8. Then I'm going to use my product property. So I know log base 2 of 5 plus log base 2 of 8. That's my property. Then I'm going to replace log base 2 of 5 with what they told me it equals. So now I have 2.3219. So I replaced that. Then I'm going to ask myself 2 to the what gives me 8. Oh, 2 to the 4th. This is 4. So if I add these two together, I get 6.3219. Oh, Okay, just kidding. Hold on. I'm like looking at this. I'm 1 power off. 2 to the 3rd is 8. So this is 3, meaning this is 5.3219. All right, another one. So part E, approximate the log of 1900. Given that the log of 19 is approximately 1.2788. So again, let's write 1900 as 19. I'm using 19 because I know what 19 equals. And 19 times 100 is 1900. So now I can use that product property. So the log of 19 plus the log of 100. Now we're going to do two things, right? We're going to replace this with this because we know what it equals. And so 1.2788. I know this log has an invisible base of 10. So 10 to the what equals 100? Well, that answer is 2, right? 10 squared. So 1.2788 plus 2 is 3.2788. All right, next one. They'd like us to evaluate the log base 5 of 4, and they've given us two pieces of information. The log base 5 of 60 is 2.544, and log base 5 of 15 is 1.6826. Okay, so this one's kind of interesting, right? Because 60 times 15 is not 4. So what's the relationship between 60 and 15? Well, there's another property I wrote down. Underneath the product property, I wrote the quotient property. And I bet you 60 divided by 15 is 4. So log base 5 of 60 divided by 15. So I'm replacing, this has the same value as 4. And now I'm going to replace this for 60 eventually, right? And I'm going to replace this for the 15. But first I have to write it. The log base 5 of 60 minus the log base 5 of 15. Now I can replace this with the orange and this with the yellow value. So 2.544 minus 1.6826, and I get a final answer of approximately 0.86. All right, next one, because there are more. Part G, the log base 11 divided by 10,000. And they want me to use that the value of the log of 11 is approximately 1.0414. You can't even see that. Okay. So again, we're going to replace, I'm going to rewrite this. So this is the log base 11 minus the log of 10,000 according to my quotient property. Okay, I'm using, subtraction is the same as writing it as one single log. Then I'm going to replace this for this, so 1.0414. Now this guy has an invisible 10, so 10 to the what equals 10,000. I would guess it's to the fourth because there are 4 zeros, but let's confirm. 10 to the fourth, yep, is 10,000. Or you could just hit log of 10,000. Either way, it's 4. So minus 4. And 1.0414 minus 4, I got negative 2.9586. Okay, moving on. They'd like us to simplify part H. So there's one property I have not used yet, log base 5 of 125 to the fourth. So there are 3 properties I listed. We've used both inverse properties. We've used the product property. The sum of 2 logs can be written as a product. The difference of 2 logs can be written as a quotient. Here's the final property we haven't used yet. An exponent can be written out front. So I can rewrite this to be 4 times the log base 5 of 125. So I'm going to bring down the 4, and then I'm going to evaluate this guy. So 5 to the what power is 125? Well, the answer is 3. So the value of this log is just 3. So the final answer is 12. Now, next one is a very complicated one. They'd like us to use all of our properties in the following. So the natural log, of x plus 2 divided by 2e squared. So let's start with the quotient property. So the natural log of x plus 2 minus the natural log of 2e squared. Okay, now let's break this up because these two are being multiplied. So the natural log of x plus 2 minus the natural log of 2 plus the natural log of e squared. Okay, now from here, I have an invisible e here, and I can bring the 2 out front. So my final answer is the natural log of x plus 2 minus the natural log of 2 plus 2. And actually, my bad, I'm minusing both of these. I'm subtracting, not minusing. So this is a minus 2. I am not going to do J, and so I am going to list for homework what we're skipping. So for this section, we're going to skip numbers 9, 17, 24, and 26 through 28. Thank you.